Welcome to this new video. The essence of this video is to show that not all functions have the Laplace transform. Okay, so we can apply the Laplace transform on all functions, and we should be able to know why and how. That's the essence of this video. So remember that by definition we say that the Laplace transform for a function f of t with t positive or 0, the Laplace transform is denoted by this and given by the following formula: the integral from 0 to infinity of e to the power minus st f of t dt. Right, this is what we have by definition. There are some cases where we have to really pay attention of the function f of t. If it's happened that the function f of t at a certain point grow quicker than the function e to the power minus than the function e to the power minus st, then in that case you won't be able to obtain the Laplace transform, because you say that the integral will diverge. Okay, so let's take this example and see. If you are given, for example, f of t is equal 1 over t squared. Let's substitute this in the definition and see. So the Laplace transform of f of t is the integral from 0 to infinity of e to the power minus st times 1 over t squared dt. Alright, as I already mentioned in the previous video, this is an improper integral, given that one of the limit is infinity. Okay, so in this case we have to introduce a limit. This is the proper way to write this: the limit when k tends to infinity of the integral from 0 to k of e to the power minus st times 1 over t squared dt. Then we can split these into two integrals. When we have the integral from 0 to infinity, we can split it into an integral from 0 to 1 and from 1 to infinity, right? So this is, we don't need the limits for the first part if we are integrating from 0 to 1. So we can take the integral from 0 to 1 of e to the power minus st 1 over t squared dt plus the limit when k tends to infinity of the integral from 1 to k e to the power minus st times 1 over t squared dt. This is what we obtain. What is this integral? Let's call this the first part 1 and this the second part is 2. For this, let's start with this second part because it's easier than the first one. First, substitution. Secondly, you do the integration by part and you find that this second part will converge. So this converges. And let's pay attention to the first part. Okay, we have to find a function smaller than what we have here, the function we are integrating. Okay, that function can be something like this. Let's take e to the power minus s times the integral from 0 to 1 of 1 over t squared dt. Here we see that the antiderivative of 1 over t squared is minus 1 over t. This is minus 1 over t from 0 to 1. And if you substitute here the limit 1 and 0, you see that you have 1 over 0, right? And therefore this will diverge. So this part 2 diverges. So by the comparison test of the improper integral, the original integral also diverges, given that this one diverges, right? In conclusion, you can obtain the Laplace transform of this function 1 over t, just because we get to a conclusion that this function diverges. So let's answer to this question. How do you know that the Laplace transform of the function f of t exists? Well, in general, if you use this definition, the Laplace of the function f of t is equal to the integral from 0 to infinity e to the power minus t f of t dt. So in general, if the function f of t was to grow quicker than the function e to the power minus st at a certain point, then the integral will diverge, okay? So in that case, you won't be able to find the Laplace transform on such function. So basically, you just have to compare these two functions. If it happens that the function f of t for at certain point grow quicker than the function exponential minus st, then you won't be able to obtain the Laplace transform of such function. All right, to illustrate this, let me give you some example. Let f of t be e to the power t squared. This is the first one. The second one, you take f of t equal t to the power t. Then, if s is positive, you compare this function e to the power t squared to the function e to the power minus st. You see that this function at some point grows quicker than the function e to the power minus st. And in that case, you won't be able to apply the Laplace transform on this function. Same for this. If you plot these two functions, you see that for s positive, you see that this function grow quicker at some point than the function e to the power minus st. And that is all for this video. Thank you.